Okay, so the next thing I want to talk about is color temperature. Okay, so we measure color temperature in Kelvin temperature. Okay, and so you look here, it says 1800 K. The K stands for Kelvin. 4,000, 5,600, 8,000, 12,000, and 16,000. The higher the number, the bluer, the cooler your images get. The lower the number, the warmer or redder your images get. Now, this has to do with Kelvin temperature has to do with an object, a piece of metal or something, and they heat it up and they burn it, and at a certain degree, it changes color. And that's kind of the basis. And and I'm kind of super simplifying it right now, but that's the kind of theory going on here. Um, so we want to start looking at the light in our world and seeing what color temperature it is. And we'll talk about more about this next class. But if you think here, if I have candlelight, well, it's going to be redder. It's going to be 1800. Tungsten lights, which is a household light bulb, and not the new LED ones, but the old school ones, the one that you would screw into your Betty Crocker easy bake oven when you're a kid and make those little wonderful cakes that were probably burnt. That little light bulb that heats up when you touch it and you burn your hand, well, that's a tungsten light bulb. Those are around 28 to 3200 K. So they're like right around this area here. So they're yellowish. Fluorescent lamps are anywhere from 4200 to 47. So right around here to here. So they're caught in the middle right there. They can sometimes have a little green hue to them. Electronic flash on your camera, 5,000. It's going to be right here in that white light area. Bright sunlight is 56K. Again, in that white area. Outdoor shade is 6,500. It's going to start shifting towards blue. Now, here's a question for you. Why do you think our eyes see sunlight as white light? First of all, is it really white?
No.
Blue.
Is color really there?
Yes.
Are you sure? What is color?
White.
It's light, but how do we know? How do I know that white for me is the same as you? This could be a philosophical question, maybe. But to answer the question, there is no color. Color doesn't really exist in the real world. It's our interpretation of our brain interpreting it. So we just think of it as white. So why would white sunlight be considered white? Well, that's the actual light that we've kind of evolved under, right? Sunlight's been the primary light source on this planet for billions of years, right? Candlelight, maybe a couple thousand years ago, came into play. Fire, tens of thousands of years ago. Electric light, 200 years ago. Not even that, 100 plus years, right? So our eyes have been fine-tuned to sunlight. And so that makes it white light, which is kind of right in the middle. If you notice, it's in the middle right here between the two ends of the spectrum. So something to think about when we start talking about color temperature and light the rest of the week. Makes sense so far? We're going to go over this again. This is all also in the modules too. We're going to talk way in more depth into this. So setting the white balance on your camera is going to determine how the overall color will look. The same exact shot, but they look two different things. I got a warmer version here, cooler version here, in the middle version right here, right? Warm, obviously, neutral, and cool. So depending about where I set the white balance on my camera, it's going to dictate what my images are going to look like. Are they going to be neutral, warm, or cool? So the thing we want to always do is start with daylight balance. Now, you can say, well, what if I should adjust my white balance to whatever the lighting is in the room, right? Um, you can. It depends on how you want to workflow, but I'm going to say most professional photographers, they're probably going to leave their white balance in the middle at daylight. And when I do that, I can see what the lights are actually doing. I can see whether they're warmer or cooler, and then I can make it. And what I'm going to say is, instead of making the adjustment here in the camera, I can make the adjustment later on in Photoshop and have much more greater control in more critical viewing of my images. So rule of thumb is to keep your camera set to daylight balance. So what are we going to set this camera at? Well, we're going to set the ISO. Remember, we're going to set that ISO based off of what you're shooting. So anywhere between, 50 and 2000 or 800 if you've got a Rebel. File format, what are we going to set that to? Probably going to set it to RAW. Color space, we're going to put that probably to Adobe RGB. Color temperature, we're going to set that to daylight. So, and again, this will might be a little scientific and a little techy, but it's always cool to know. The more you know, the better you know, right? So again, no quizzes, no nothing, but this is just to throw you at so you can wrap your head around this. What color temperature really is. So our eyes see, the light our eyes and camera sees part of something called the electromagnetic energy spectrum. You're like, whoa, what the heck is that? Well, the same energy, the same that allows your phone to talk to other phones, the radio waves that come out of here, the AM and FM radio waves in your car stereo, the TV signals you get into the air, the cell phone connections, the energy that cooks your food in microwaves, the energy that goes into looking at the bones in your hands, they're all the same energy. It's all the same stuff. It's called electromagnetic energy spectrum. And it's just the different frequencies of it. So when I get down to here where it says broadcast band, well, these are all, stuff for TV transmissions. The waves, which is like the crest, if you imagine a wave, like you drop a rock in a pool and it makes those waves that go up and down, like also like being at the beach. The distance from the top to the bottom of the wave is called a wavelength. And so when we stretch them out, like broadband, these things are like a kilometer long. And then we move into radio, which is like the radio that we tune into in our car. They're a meter long. We get into radar, like the cop's got the radar gun and he's catching you, 1 millimeter. And we get into microwaves too, and like where I'm getting my food cooked. Okay, well, that's right around there. Infrared, if anybody shot infrared or use those night scope or have seen it in movies, it's right here. And then boom, look, we've got this little rainbow here. This little tiny slice of all this energy is what our eyes see. So if our eyes were, tuned to microwaves, then we would see microwave energy in your food when you cook it in your microwave oven. But we don't. Our eyes are tuned to this little area right here that's called visible light. And on one side of it is infrared light, which is, the stuff people see when they're doing low light nighttime shooting, right? When it looks all green and everything. Above it, ultraviolet light, UV, right? And everybody knows what ultraviolet light is, right? You get sunburn from the sun, right? So it's the same energy, but we only see a little slice of this vibration. So above it, we get X-rays, again, seeing into our bones. Gamma rays are stuff that comes from outer space. Cosmic rays, all, these things, not quite too healthy for us to kind of stay away from all this stuff. But here, this is what our eyes like to see. We only perceive a tiny little fraction of this spectrum. So that's why some cameras can see infrared or or we put an ultraviolet filter on and we can see ultraviolet, photography. Infrared, I'm basically extending the range that the sensor can see a little bit lower than visible light, and I can basically see stuff, heat off of people. I can see night in the nighttime with almost no light. Makes sense? Crazy, right? Isn't it crazy? So Just like this, all that light sources have different color temperature then. Our eyes automatically adjust to see white light. So when you are inside your, in your room and you've got regular 32K tungsten light bulbs going on, like right now in here, I've got 56K lights, and in the back there, that light is 32K. Notice it looks yellower. It looks a little more yellow. In fact, if I turn it down a little bit, turn it down, you might be able to see it a little bit better. Let's see. Yeah, see how it looks yellow? It's a
Yes.
different color. It's a different color temperature. Our eyes are really, really good at seeing, adjusting automatically. So when you are inside your, in the house and you go outdoors and you burst out the door and it, you're like, it's bright, but then your eyes adjust. You don't look out and say, "Hey, everything looks blue," because the daylight is or actually is much more bluer than the tungsten light. Our eyes automatically adjust for that, and so we don't really perceive it. In fact, you can train yourself, and I have trained myself where I can see color differences. I can see the difference in tungsten light versus daylight versus outdoor shadows. I can tell you if it's 44K, 56K, 800K, and so forth. You can train your brain to do that. I've done it because that's what I've been doing so long. I need to know, in a professional environment, what each light's doing, what the color temperature it is. And yeah, I could have a meter that reads it out, but after doing it so many years, I could just kind of see it and guesstimate and know what it is. So that's one cool thing you can do, is kind of train your brain to do that. And even if you go outdoors, and you can try this next time you're outdoors, take a piece of white paper, notebook paper, and you kind of hold it up in front of you in the sunlight. And let's say you're standing next to a shaded area, quickly put it in the shade and look at it really quick, and you'll see it's bluer. Your eye will catch that before your brain makes an adjustment. You'll see it's bluer. So the lower the Kelvin number, again, the redder the image. The higher the Kelvin number, the bluer the image. Kind of, same thing here, warm, cool. And so 56 is the neutral because it's the middle of the spectrum. Daylight's neutral because it's 56. So we want to kind of start that way. We want to, if you set your camera to 56, it'll be neutrally in the middle, and you can kind of see where all these lights kind of what they do. So if you leave your camera in auto white balance, it's automatically going to normalize the color. It's going to try to make it normal, just like the auto exposure in your camera tries to create normal exposure. Same thing here with the auto white balance. It's going to try and normalize it. So if we set our camera to 56 in the middle, it's going to allow us to see what all the lights going on in the scene that you're shooting. And so by doing that, I can see how different lights have different color temperatures and how they react. So when we start doing this next assignment, we want to put our camera into 56. And almost all professionals will put their camera into daylight setting on their cameras. Now, granted, there are definitely situations where I don't do that. If I'm shooting interior and we're shooting, I know for sure that we're shooting everything in 32K. I'm probably going to put my camera at 32K for that. But that's for a professional environment. But for us, we're going to want to, if I'm going to do major color correction or any kind of correction later on, it's better to put it in the middle, and then you can have that luxury of adjusting down the road. And don't worry, we're gonna talk about this in more detail next class. The last thing I want to talk about a little bit is about how to create slow shutter images for the next assignment that you guys are working on right now. So remember, slow shutter is where you're going to let the camera have a long exposure, and I can either do light painting and move stuff around, or I can do the shots where, I go outside, shoot downtown LA and at night, and I get all the cars with the motion blur in the cars happening. So what do you need to do for that? Well, here's a little cheat sheet right here to kind of help you out. The first thing you're going to need to do this is a tripod. It just is not going to work if you handhold it. You're just going to get a blur. Even if you are amazingly good at holding stuff, forget it. It's gonna create motion blur. Even if you want to use your iPhone, you got to put it on some type of tripod-like thing, even a stable. In fact, I just ordered, I think it just came in today, found this really cool little portable tripod for iPhones that you could fit in your wallet. And so I'll check it out. And if it's cool enough, I'll give you guys the link so you can see it. So you can have a portable tripod with you all the time. You just carry it with you. Doesn't take up any space. So you need a tripod, first of all. You need the camera also to be set in the manual mode, because if you leave it in auto mode, now granted, yeah, it's going to be noisy or it's not going to work. You have to make sure the ISO is set to manual and avoid high ISOs, because it's the opposite. We don't need high ISO when we're doing long exposure, right? Because remember, we have that faucet open for a long amount of time. Even if the water is just dripping in, if I let it open long enough, it's going to collect enough light to expose the image. So most slow shutter photography is actually low ISO. So you could go, you're thinking about 100, 200, 400, 800. That might be the overkill, 800, depending on how long it is. So you want to set your ISO into manual. You want to turn off autofocus, because it's going to hunt for the focus during this, and you don't want to do that. So you're going to have to basically set focus manual and then leave it. The other thing you want to do is, if you have any form of image stabilization on your lens or on your camera, you want to shut that off too, because even if it's on a tripod, that stuff may move around a little bit and then cause motion blur happening where you don't want it. So some Sony cameras have built-in image stabilization into the body. Certain lenses will have it. So for example, on this Canon right here, I've got a switch here that says stabilization. And so when I'm on a tripod, I'm going to turn it off. When I'm doing handheld, I want to keep it on, because it's going to help compensate for some of the motion blur. But when I'm on a tripod, I want it off, because it's going to interfere with this process.
I've always wondered about that. So thank you.
Yeah. So turn it off when you're going to shoot this stuff on a tripod. In fact, anytime I put a camera on a tripod, I turn it off. Even if it's not going to be long exposure. So keep that off. Remote shutter or timer, and this is the other cool thing, because if you just take a picture and put your finger on there and the shutter goes off, your finger may shake the camera in the beginning and create a little bit of motion blur. So if you've got a newer camera that has Wi-Fi and you've got an app on your phone that control your camera, awesome. That's what you want to use. If not, you can buy some of these cameras. I know this camera, I can buy a remote shutter that plugs into it on a wire, and I can hold that and hit that instead of this going off. That's another way to do it. If you don't have any of those things, there should be a timer mechanism on your camera that can allow you to have like a 5-second delay when you hit, so you can hit the shutter and then it'll count down 5 or 2 seconds, whatever your camera is going to set up, and then it takes the picture. And so if I do that, then when I hit the button, if I shake the camera for a second, by the time that the shot goes off, it won't be moving anymore. So this is kind of what I do to kind of set up how to do slow shutter stuff to be successful at it. Yeah, so again, shutter, tripod, yeah, you want slow shutter. You want to not move stuff. Basically, we talked, this is going a little bit more detail what I talked about. Shutter, ND filters. Slow shutter work during the day. Like if I'm at nighttime, no, I'm not going to need any filters. But if I'm at the daytime and I want to do a shot where like there's some water going down a waterfall or a fountain, and I want to kind of motion blurry, I'm going to need some type of neutral density filter because there's going to be way too much light to be able to capture it, and it's going to be overexposed. So might be, we talked about those neutral densities you can kind of put on the front. We can screw those on and use those, and they come in variable sizes. You can buy a variable ND filter fairly cheap on Amazon to do this stuff. So if you want to mess around with any long exposure during the daytime, you're going to need some form of an ND filter. And what do you need? Well, again, you're going to have to measure the diameter. In most lenses, if I look on the on the front of my lens here, so if I take this one off, if I look in here, you're going to see right down here a number. Right on here it says 77 millimeter. Well, that's the thread of this lens, 77 millimeters. So if I go on Amazon and order a filter that has 77 millimeter on it, there you go. It will. I know it'll work on this lens. And I can just buy it. I can buy ND filter, a variable filter. This is a clear filter I put on to protect the lens so it doesn't get scratched by accident. But that's a way you can buy some. You can get really inexpensive filters on Amazon. And obviously there's different, prices anywhere from 20 bucks to 200 bucks. And it just depends on what your budget is, but anything is better than nothing. Let's put it that way. So if you can only afford a $20 ND filter, that's better than nothing. So get it. To gain correct exposure, you're going to need to carefully manage the aperture and the ISO. So when the sensor is exposed for longer, more light will hit it. So if you don't control the aperture, your ISO image will be overexposed. So that means I gotta make sure the ISO is in manual. If I leave it in auto, it's going to jump all over the place and it's not going to work. And so what's the best slow shutter speed to use? Well, there's no hard or fast rule for that. It's kind of an experiment. You're going to have to kind of test and try it out and see what works for you. Because every situation is going to have different challenges. Those challenges include the amount of light available, the purpose of your composition, how much motion blur do you want, etc. There's some, again, this is an experimental thing. So I suggest when you guys go to shoot those shots, just start experimenting. Just see what works and what doesn't work and keep track of it. And the great thing is if you're using Bridge, you can go into Bridge and look and see exactly what the settings were on the camera. So you'll know, like, oh, wow, okay, no, this scenario works for this type of shot. Cool. So how to get creative with motion stills? Well, you can do motion blur like this, where you just let it run and you've got all these cool lines blurring. That's always fun. Again, there's some information here to do that. I'll let you guys kind of go through that so we don't take up too much time. You can do intentional camera shake. So a lot of cool things. So this is one example where you might be handheld. You're going to take a picture, and as you take the picture, it's do a little small shake at the beginning or the end of the image of the exposure, the shutter, and you can create a little bit of this kind of weird motion blur. Can make things a little more dynamic. We talked about this, the panning track, right? You can just take a picture of a longer shutter, and if you're keeping the same speed as your subject, you can get a shot like this. Flowing water, okay, yeah, we kind of talked about this. So you can kind of do this. Usually around 1/15 is a good place to start, and then go longer. Light painting, oh, this is the fun one. This is one I hope everybody tries out. So here, obviously, you're going to need a camera on a tripod. This is going to be long exposure. So almost sometimes the longer, the better. Things to remember here is that your subject, if you're shooting someone like this, they got to stand perfectly still. They can't be like this. It's like if you're going to have the shutter open for, 10 seconds while this happens, or half a minute, they have to stand perfectly still. So that either means they're in a chair like this, or if they have to be pretty good at standing, not moving. So you can use LEDs, you can use glow sticks, you can use any light form you can know. You don't even need a very powerful light form. You can literally take your phone like this and move it around at nighttime and create interesting patterns behind someone. The key here is, if you're going to have someone do the painting, is that they don't stand still. So if I have someone standing like this, take a picture, and then I'm behind them doing all the painting, I got to keep moving. If I just stand there and do this, you're going to see me too. So that means as it's happening, I'm just going to do this. I'm just going to go move my body around so it doesn't give enough, collect enough light on the camera, and then I'll kind of be invisible. I remember I showed you some examples of that where, you know, there's people you could catch the person doing the light painting. So this is fun, you know, but it takes a little bit of time. So this might be a cool weekend project, do something, or try it at night. If you got an hour or two to kill, set something up, find some different lighting tools, you know, again, phone could work, glow sticks, little LED flashlights, whatever you can find. I guarantee you anything will work. And try messing around with that. And you'll probably discover that you can do some cool stuff. Any questions so far? Too much, too little information?
Just the right amount of information.
Okay. Okay, so that kind of covers about what I wanted to talk about today. So unless you guys have any more questions or comments or anything, I'm gonna kind of end it now. We are gonna pick off with talking about dramatic light and a bunch of other stuff, and we'll get into the next assignment and what settings to do and so forth, but we'll leave that for Wednesday. So anybody got any questions?
No.
All right. Well, hey, have a great Monday. Enjoy the
You
rest of your day.
You
And
too.
I'll see everybody on Wednesday. So
Have a
take
good
care.
day, Professor.
Bye.
Hey, Professor.
Bye-bye.